Hello everyone, today we will start root locus and we try to learn it very easy way. What are the steps that you can follow and you easily learn the root locus. So the root locus basically start from with you have an input and output. You have this feedback system that is with k, g of s, h of s. Actually root locus gives you the locus or path of the poles and zeros as you vary this k. So this means that you normally in root locus you design k, so it is actually design a gain controller. So how you do that, you actually take the denominator of closed loop transfer function y by r, that becomes 1 plus k g of s h of s equal to 0, is also known as characteristic equation. Now there are 2 points that need to be satisfied so that you you can draw the root locus. First one is that if I take the magnitude of this k, g of s, h of s, is also known as open loop transfer function, must be equal to 1. If I take the angle of this one, it becomes plus minus 180 degree times 2k plus 1. So these are the basic concepts that used to design the root locus. But the question is how you do that. Now first point that you need to know is that root locus with k equal to 0 starts at poles and finish at zeros with k equal to infinity. So the main idea is that your root locus start from pole and finish at 0. So here your value is k equal to 0, here value is k equal to infinity. So we are talking about for positive gain. Okay, second thing that you must know that is real axis behavior of root locus. Now what is real axis behavior? Means that root locus exists on the left side of odd number of poles plus zeros. So these 2 points, if you know that, you can easily draw any root locus. Third point is that if any pole or zero missing, then that will be at infinity. Means that the idea is that there is always a pole and there is always a zero. If you get a transfer function with less number of poles or zeros, that poles or zeros must be at the infinity. Now let's start it. So first thing is you have to make an S-plane here. This is your real, this is your imaginary. Now first of all, for example, if I want to make a root locus for a system with given is that k, g of s, h of s is equal to, let's assume that k times s plus 3 divided by s plus 2. How you do that? So first point is to plot this the poles of this open loop transfer function, that is k, g of s on s plane. Now we know that pole is at -2, so for example if this is your -2 and you have a 0 at -3, now j omega axis, and we have to apply the rule of j omega. J omega axis says that if you look in this direction, okay, and count the number of poles and zeros. Now here there is no pole and zero, so means that number is even. When you come to this portion, this portion of real axis, there is single pole, so this means that number is odd. So you have a root locus that will start from here, because it will start from the pole and up to the next pole or 0. Okay, now we find a 0, so this means that this root locus will start from pole and finish at 0. So this is the root locus for this particular example. So it's very easy to draw. Now let's consider another example. So it is a very free for example, if you have a pole here, another pole here, and you have a 0 here, how root locus look like? Now in this case, if I choose medium color, so because we know that there's nothing here, so root locus will start from here till here. Again there's nothing, then root locus is on this thing. Now if I make the arrow here, so it will start from here, again start from here, it will finish at here. Now the thing is, how we know that? Because it didn't finish on the pole, it must finish on the 0. Now 0 is here, so it is unable to come here, so it will jump from here and move to this direction and finish here. One pole, for example this one, the other pole will go in that direction and try to come here and then move in this direction up to the infinite. So this is the idea. So for this idea, the thing is, you have to count the number of zeros. So number of zeros here is 1 and number of poles is 2. So you have a 2 minus 1. Now difference is 1. So this means that you have one branch of root locus at infinity. So this is the way you can easily draw the root locus. Now consider another example. Now I make a bit if we have a complex poles, how we solve this thing? Now again nothing here, it will start follow the same rule, because this we didn't play any role on real axis, though it will start here, again start here. Now there's nothing here. Now how we know that what happened? So because the number of poles is 4, number of zeros is 0, so difference is 4 minus 0 is 0. Now how you know that, in which direction it will follow? So let's consider a pizza here. So if I want to cut into 4 parts, there are two ways. Either I have to cut in this direction or I have to cut in that direction. So we have to consider this. This is your real axis, and this is again real axis. So if I look here, there's no branch going to the infinity, so this means that we have root locus only in this direction, so there's no branch on the real axis. So this is not possible here in this case, so this is possible. So this means that root locus go in this direction, one goes in that direction, other goes in that. Now so this means that you have for example, if this is known as asymptotes, I draw somewhere here asymptotes like this. Okay, so this means that it will follow the root location. Sorry, I just rub it. Okay, I make it again somewhere here. It will go in this direction, other will go in this direction. We have to know how to calculate this point, okay, later on. So this means that this will follow this branch, root locus will go in this direction. Okay, similarly this branch will follow root locus going in that direction, and this branch will follow root locus, sorry about that, in that direction, and similarly this branch will go in that direction. So this is what you get root locus. So now the question is, how we know all this about that this is correct or not? So for this we have to do some calculations that will tell us that either they follow this direction or not. Okay, so this is freehand sketching that you can use to plot the root locus. Now consider another example here. An example, if I have 0 here, 0 here, 0 here, one pole here, another pole here, another pole here. Now how we know the rule of real axis, we use it. We have to start from here. If I make this is covered by the root locus. Similarly, this portion is covered by the root locus. Now this will start in this direction and here. Now in that direction it will start here and goes up to infinity. Now how root locus will behave? Now the thing is one point is going to the infinity. How many poles we have? 1 2 3 4 poles and 3 0. So 1, so we have number of poles equal to 4, number of zeros equal to 3. Now difference is 4 minus 3 is 1. So one pole is going to infinity, so this is the one that is going to infinity. Now this will be come to these zeros. How it will goes, let's see. It will come in that direction, it will come in that direction, because poles always reflect from the pole, repel from the pole and attract towards the zero. So this is the root locus. You can have it. Later on we will calculate how to calculate this angle, how to calculate these angles, but this is freehand sketching that you can perform using root locus. So let's consider another example. So if I have a pole here and a 0 here and a 0 here, so in that case we have here and here is our root locus. It will start in this direction, it will finish here, one will finish, so one will come in this direction and finish in that direction, other will come in that direction and go in this one. So this is the root locus. So this is the way to easily freehand sketching for root locus. So I will stop here. Thank you.